Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. I am Vangelis and today you will be watching Web API benchmarking, Rust ntex, Tokio async standard, Gloomio vs Rust actixweb. First of all, before I get into the video, I want to say that I haven't uploaded a video for some time now, so I am not consistent in uploading videos because I don't do YouTube as my main, let's say, thing. Neither do I want to do YouTube and content creation as my main thing. I have other things to attend to, like actual work and other stuff, so this is why I am not consistent with my videos. Neither should you expect me to be consistent with my videos. Whenever I have something that I feel it is important to show, to create some video about it, whatever new and whatever useful, I will create a video. So yeah, that's it. Having said that, let's get into the actual video. And today, as you can see in our title, we will talk about ntex, which is another framework, another Rust framework, and this is it. The special thing about it is that this is created by the original author of actixweb. So this is the guy here, Nikolai Kim, who is a Microsoft guy, employee. At least he was, I'm not sure of his status now. And after the drama of actixweb, if you are not familiar with what happened with actixweb, you can look it up. There was some drama and he left from the project. And apparently he has created this new project, which I am not very familiar with myself, but I at least decided to create a benchmarking video using this framework too. And the other special thing about it, apart from the creator, is that this framework gives you the ability to choose your runtime. So as you can see here, it says that the runtime must be selected as a feature, and these are the available options. So I am not aware of any other framework that gives you this ability to choose runtimes in this way. Maybe there is, maybe there is not. I am not aware of it, but I found it very interesting and I wanted to test it out. And I also wanted to benchmark these different runtimes within the ntex context, and this is what we are going to do. So since we have to test all these different runtimes, the video will be a little long. I will have all the benchmarking stuff available in the video description, so if you don't want to check the video, you can check the stats on their own. And also to say for all the guys that send me messages, etc., that these benchmarks are BS, etc., I have already created my answer on that. You can check my previous videos, my response to such feedback. So yeah, if you think that they do not provide anything useful, you can just skip the video, don't see the video. Or if you think that you can gain some insight, some useful info, you can see the video and the stats. So let's start. As we said, we will test actixweb against ntex with its runtimes, and the first setup is actixweb with ntex Tokio, as you can see here. And if you check the code here, this is our cargo toml file, and this is how we will be proceeding. First of all, I'm using Tokio as my first runtime option, and I have mapped this to here, to this key of this data structure, of a user data structure. So we will be sure that we are running the correct stuff, and currently we indeed run Tokio with with the Tokio runtime with this data. So let's come here and let me rerun just to be sure. So we are running. Let's recheck. Okay, we are with Tokyo. Let's also open up our sister monitor in order for us to be ready for the benchmarks. And let's start by benching actixweb first. We will use OHA and let's see what happens. So starting actixweb, CPU 65, memory 14 for OHA. So OHA CPU 64, RAM let's say 15. I'm writing the stats down. $64.15, so we are stable there. I also hope you checked, so we have the stats. Okay, cool, let me get them. Copy. I'm writing the stats down here for every one test that we will perform, and they will be available, as I said, in the description. So let's go here with ntex for ntex, Tokyo and OHA. Copy. Insert. Okay, let me prepare this and let's run. Ntex Tokyo OHA. What do we have? CPU 64, memory 26. CPU 64, RAM 28, 26, let's say 27. Let's say 27. (62) CPU, 63. I will say 63 CPU. Okay, we have our results. Let me get these two. And let's compare this initial run. Success rate okay, total 51 seconds, 50 seconds, slowest 0.0390. This is a little bit more slower. Fastest the same, average 51. This is, yeah, they're almost identical. Request per second 19,518, 19,821. Total data size request, okay, it seems that ntex with Tokyo is a little bit better. Response time 001, 003, 004. You see that for both of them the most of the requests are within this amount of time. So similar here too. Latency distribution 10% int 18, 25, 27, 50, 75, 63, 90. Here we have some difference. So again, ntex Tokyo seems a little better here, and here, yeah, a little bit better overall, I would say. And everything was okay, 200. So yeah, we have a little bit of difference here, and ntex is a little bit faster for Oha. So let's proceed with no, let's do it with all the runtimes. We will test all the runtimes for ntex with Oha and compare, and then we will do it with WRK. So let's go, let's kill this, and we will go to async-std, and also we will go here async-std, and we will run. Okay, let's check the browser. Cool, we have async-std, and now all we have to do is rerun the Oha command, and let's check what's going on. So CPU 59, it's less, CPU 60, a little less CPU utilization, 60 to 58, and memory 30, let's say 30 megabytes. So a little more memory, marginally more memory, and marginally less CPU. So let's check the actual results. Yeah, the CPU and the memory is consistent, as you can see. So we will say CPU 59, we will get the mean value, which is, let's say, 59, and RAM 30, and let's compare. Let me get these two. Copy, this is for async-std. So let's compare. But basically, we should compare not with actixweb, but with the previous results of ntex. So let me bring this up, and we will compare to the results for ntex and Tokyo. So let's compare and see what's going on. So we have 50 seconds, 57 seconds overall. So async-std needed more time to perform the requests. Slowest about the same, a little bit better here. Fastest the same. Average 50 better. 19, almost 20,000. Here we have 17.2 thousand requests. So ntex with Tokyo is better. Total data, this is less data, which, yeah, I don't know why. Maybe we have a difference in our response. I don't know the actual bytes that we return. If they differ, probably they differ. Size request, okay, yes, we have a difference in the size request. Size per second, as you can see, ntex with Tokyo was able to provide, to serve more data per second. Also, we have a difference here in the distribution. You see that for Tokyo we have a better timing than the async-std, as you can see here. Let's check the latency. Yeah, the latency also is better here for Tokyo, as you can see. At first glance, all the numbers here are better across the board for all distributions, and everything was a success. So okay, do I have the results? Yes, I have the results here. So we see that async-std is worse, let's say, compared to Tokyo for the ntex framework. So let's proceed to the Gloomio now. To Glommio, not Gloomio. I really don't know anything about this runtime. I don't know if it is considered a good option or not. If you have any insight on this, you can provide feedback in the comments, of course. And I would like to learn more things about this. Maybe I will do some time. So let's come here and let's rerun. And let's what we have in the browser. ntex Gloomio, yeah, we are correct. So let's rerun. This is the results for Gloomio. And now we want this, and we want the system monitor, and we want to rerun the command. Let's see. 64 CPU and the memory 192. Huge memory consumption for this runtime. So we have RAM, let's say 195, and CPU, let's say 62. We have a very big difference in the RAM usage, as you can see. The CPU is approximately the same, but the RAM usage is a no-no for me because it is a huge difference. Many orders of magnitude bigger memory consumption. Let's see our results. Copy. We are in ntex Gloomio, so let's come here to ntex Tokyo and let's start comparing. As you can see, we had 63 CPU and RAM 27 for ntex Tokyo, and for Gloomio we have 62 and 195 RAM, so huge difference. Maybe I compare them like this. Okay, this is better. So total time 50 seconds, 55 seconds. So Tokyo is better. Slowest, this is worse. Tokyo is better. Fastest, the same. Average, Tokyo, ntex Tokyo is better. Request per second, ntex Tokyo is better. Total data, less data, probably the request. Yes, this is a smaller request. Okay. The size per second, again, ntex Tokyo is better. Response, we are approximately the same distribution here. As you can see, most requests were in this time of amount of time. The visuals are quite similar here, which is good. Latency distribution 10% in 18, 20, 27, 30, 42, 46, 63, 70, 92, 103. Yeah, overall, as you can see, Tokyo has better latency times. Overall, across all the percentages, as you can see, the time needed is less, the latency is smaller. Yeah, so overall, as we can see, ntex Tokyo outperforms ntex async-std and ntex Gloomio and actixweb. So these are the initial results that we get. So now we have to proceed to the WRK test. So I will come here and I will say that I want to test my actixweb. Let me prepare this. Okay. So these are the amount of requests that we will perform for 30 seconds. As you can see, these are the stats. You can run them yourselves if you want. So let's check. And now we are running WRK, and we have CPU is 40 and RAM is 121. RAM is 121. 120, let's say. CPU 40, RAM 120, okay, and we are done. Let's get this. Copy. Excellent. And now let's proceed to, we have to kill this and we have to restart here with Tokyo. So let's rerun. Running, let's check it. Okay, we have Tokyo. So let's run our benchmark here too. And let's go to ntex Tokyo and say that we want the WRK, which says that we use 85% of our CPU, which is nice, and 13 megabytes of memory, which is also very nice. And let's check the actual results. 2513, 8513, sorry. So let's get the results, copy for ntex Tokyo, and let's compare. Okay, latency 91, 97 for the average. The average here, as you can see, is hugely different, a lot better. Max 138, also here better. Request per second, huge difference here. 4.51 and here 1.72. Max 2.4, 6.07. We have a huge difference, as you can see. Requests per second, 308, 181, 808, 487, more than double the throughput, for ntex Tokyo. Requests per second 10,200 to 26,800. Transfer rate again double and more than double, as you can see. So yeah, and also the CPU and the RAM. Let me come here. This is the actixweb WRK results, and this is the Tokyo, ntex Tokyo. As you can see, we have 40 for CPU, 40%, and we have 85% usage for the CPU and 13 megabytes of RAM used. So you see the difference here and the difference in the results. So for WRK, ntex Tokyo hugely outperforms actixweb, and keep in mind that my setup is the same regarding the CPUs that I use. I use the logical CPUs in both cases. The NAM CPUs get, and to demonstrate the point, we will check it here. We will say less src librc, and we will get down here, and you will see that this is where my function runs, as you can see, and my workers are the NAM CPUs get, not the get physical. So we are working with the same setup, as you can see. And ntex Tokyo outperforms hugely actixweb. Of course, I don't know, I haven't checked the source code of ntex. I don't know if it uses Unsafe, because this was a controversial point regarding the actixweb when the man in charge was the initial creator of actixweb. So maybe in ntex he also uses the unsafe keyword, he uses unsafe code. So you have to keep this in mind if you are interested in this thing, the unsafe Rust code. But as we can see, the results are quite astonishing comparing the two frameworks. Okay, let's proceed with the next runtime. So what we want here is to say that we want the async-std, and we want to come here and we want to kill this and not this, and we want to rerun. This is what we want. Yeah. It is running. Let's check our browser. We are correct, and also, as you can see, the code is the same. We are returning 1000 users here. So same setup. And now what we have to do is rerun the benchmark for the async-std. So let's run. And let me get this. And let's see, async-std, we have CPU 82, and RAM we have 65, which is not very bad. The CPU utilization is good. The memory is worse, but yeah. Let's get the results to here. Copy. And let's compare. So we'll come here, we will split this and we have this. So this is ntex Tokio and this is ntex async-std, and we are checking this. You see the CPU is about the same, the RAM is very different. Tokio uses a lot less RAM, and let's now check the stats. Latency 35, 38. This is better. Max 138, 121. This is better here, but let's check the overall results. Requests per second 4.51 for 4.34, so this is similar. Max 6.07, 8.15, this is better for async-std. Total request 800,000, 700,000 approximately, so here we are better. Request per second 26,800, 25,800, so approximately 1,000 requests more per second. And the transfer is the same, as you can see, approximately the same. So yeah, async-std is similar to Tokio within the ntex context, and both of them are quite faster than the actix-web, because as you can see here, the CPU is 40. We are not taking advantage of the CPU as much as we could, and the RAM is worse again. And you can see the stats. You see that we have 10,000 requests per second, and here we have 25,000 requests per second with async-std. But again, I'm stressing that I don't know if there is unsafe code in ntex, which is very easy to check if we run a grep command on the source code. So let's go to our Gloomio implementation, and we'll come here and we will say this, and we will also say this, and we will kill this and rerun, and we will check our browser. And we indeed have Gloomio, and now let's rerun. Let's come here, let's prepare this, and let's rerun. And let's say CPU 84, CPU 84, 85, 84, memory 250, RAM 250. So the RAM is again worse than Tokio. At a first glance, as you can see. And now let's compare. Let me get these results. Copy. And let's compare. Let me break this here. And let's break this here, ntex Tokio with ntex Gloomio. CPU, as you can see, approximately the same. The RAM is hugely different, so kudos to Tokio. And latency 35, 36, let's say the same. The max is very similar too. This is better, of course. Request per second 4.51, 4.37, similar. 6.07, 6.78, similar. Requests per second, this amount, 800,000. 783,000. So again, we are better here in the final throughput. Request per second 26,000, 826,000. Approximately, as you can see, let's say very similar throughput. So Gloomio also delivers here regarding the performance. It is a little worse than Tokio, but overall it does a quite good job. But all the instances of ntex are quite better regarding their performance when compared to actixweb. And let's check this one. As you can see here, also the difference is huge here. And what we can say from this comparison is that actixweb is not taking advantage of our CPU at a certain extent that we would wish it to do so. For example, if we used 80% of our CPU, I suppose that our results would be a lot better, but for some reason actixweb does not take advantage of our CPU, and in order to confirm the results I will rerun this benchmark just to see if we have similar results, and I will also kill this. And this is the command, as you can see. So we have the URL, duration is 30 seconds, 1000 concurrent requests. So we have the same setup. This is the warming up, sorry. Yeah, the second one is 1000 concurrent requests, as you can see, and the duration is 30 seconds. So the setup is the same, we are correct. So let's rerun this just to be sure. And let's monitor the system. So as you can see, we have similar results. The CPU utilization is very low and the RAM is the same. So our initial results were correct. This is not a fluke. You see again that the CPU utilization was the same, was 40 and under 40. So this is not a fluke. And again, the actual result is, as you can see, comparable. So we are correct regarding our results, our actixweb results. Okay, so to sum up, as you can see, let me close this down and let's come here to ntex to give it the kudos and the props that it deserves regarding its throughput. So we see that ntex is outperforming actixweb, and the best option regarding the performance of ntex seems to be Tokio. So yeah, this is the result. The only thing that we have to check, as I said, is if it uses unsafe code, and since we are on the subject, let's do it live. Why not? Let's copy this and let's let's go to cd temp and let's cd ntex let's check grep irn unsafe. Yeah, it seems that there are instances of unsafe. Let me close this. Let's close these, let's close these, let's close these. ntex. As you can see, we have 180 instances of Unsafe within the ntex repository. And let's check some of the instances. Mask RS, config RS, decoder, encoder, dispatcher, config, IO RS, buff implement, unit slice, buff mute, bytes, self-advance, let length remaining, let inner, yeah. Okay, this is just out of curiosity what I'm checking right now, but as you can see we have instances but we have also this, as you can see, yeah. So we have to remove this. Unsafe, ntex, and we have to remove those instances of unsafe. And we have to count them. So we have 162 instances of unsafe of the unsafe keyword. So the answer to our question if ntex uses unsafe is that it does use an unsafe. Of course, I am in no position to review the code and provide feedback on whether these unsafe instances are in essence safe, because unsafe only denotes to the compiler that you can do things that they are, let's say, forbidden otherwise. It doesn't always mean that the actual code is unsafe if you know what you're doing. But yeah, if somebody is concerned about the usage of unsafe, he has to keep this in mind and pick the framework of his choice, taking this also into consideration. So this was the content of this video. This is all that we wanted to check and answer. I hope you find it useful. So thank you for watching, and till next time, have a nice day.